This is part 2 of lesson 13, and we're just going to go through and review the things that we did in class last Thursday before we finish off with what we had. So you were given a chart, this chart here. You were given that chart and some graph paper, and you had to pick out the two important items to put on the graph paper to make sort of a scatter plot. And then once you did that on that graph paper, this is what it looked like if you hit it right on the dot. And what you had to do after that point was to figure out how you could fit a sine curve to that, given that a sine curve is not going to have different maximums and minimums throughout. It's going to be a consistent sine curve. And when you did that, it should have looked like this is what it is over here. That's the sine curve, the most precise one that you could fit to it. Notice that some of the points don't touch it, but just as a best fit line in linear regression, you could fit to it. So you do the same thing with a sine curve. And then from that, we had to answer some questions about that. Now, this video is out of sync, but still it records everything. We need to come up with the function for this. So let's see how close we can get to it. And remember, we're starting with this. Y equals a sine of w quantity of x minus h, close quantities, and plus k. We had a midline on this. What did we say the midline was for the problem? See if you can do it without going back and looking at the other stuff, and we'll see how close we get. What was the midline? 1.2? I think, didn't we have 1.25? I'm guessing too. It was in here somewhere, like I have to get my line tool out. And, okay, there it is. 1.25, so here's 1.3. So just a hair below that, we'll make that 1.25. And we'll write that in. Midline 1.25. Okay, so if we have a midline of 1.25, and this stuff is touching the x-axis down at the bottom, where could I put that 1.25 into this function? Would it be for the a, the w, the h, or the k? Not the w, not the h. Not the x. The k. Alright, so we'll start there. That eliminates pretty much everything. So we'll keep this, and we'll go plus 1.25. Okay, can we get the amplitude out of this? Like from here down to there. What would that distance be? Well, this is 1.25, the midline, and what is this point here? 2.5? We'll say 2.5. So what's the difference between 2.5 and 1.25? 1.25. Okay, so where can I put that 1.25? A. Alright, so let's add to it. 1.25 sine, and we got to keep this the same for now. 1.25. Alright. And now for the W. Yeah, question.
Alright,
we can probably do the W in there. We can do the distance between two minimums or two maximums and come up with some kind of a distance on the x-axis, like from here to there. What is that distance? 12. Yeah, we came up with 12 before. So we'll try 12 on this one. So if we have 12, it took us 2 pi for one revolution, and the distance on the x-axis is 12. So if we reduce that, we can come up with pi over 6. Alright. So y equals 1.25 sine and then we'll have pi over 6 times x minus h, close quantities, and 1.25. Now, in order to get your h, usually what you have to do is to figure out what we have to do to get it to move over to 0, like on the Ferris wheel, and we'll see how close we can get this one. But if we want this one to start at 0, then here's our shift over here. One of these is 2, and this looks like a 2 there. And that may be why they've made this the way it is, hitting that negative 2 out there. So how far would I have to shift this over to make it start at 0? 1 block equals 2, so we're shifting it how far to the right? 2. So if we want to shift it 2 to the right, we could come down here and redo this. Y equals 1.25 sine pi over 6 x minus 2, close quantities, 1.2, strange looking 2, 5. Now remember, we're doing this from estimating on the graph, so ours may be a little bit different than what comes up to be the precise answer. Like what the midline was. We found that the midline was closest to 1.25, and we found the amplitude to be 1.25. And then the period is 12. What's the distance on the x-axis that it takes for it to make one revolution? And then you have to estimate the distance between between a point on the graph that crosses the midline and the vertical axis. Estimate the horizontal distance, which is this way, between a point on the graph that crosses the midline and the vertical axis. And here's what 12.5 hours. I think we did that one as well. We came up with a 12.5 when we went through it. But then we have to write a function. You have to write a function of this form, just like we did with the Ferris wheel, to model these data where x is the hours since midnight on May 21st and f of x is the height in feet relative to the MLLW. So we can go back and look at that graph if it still shows up on here. I don't think it does, so we'll have to go back to the other screen. And there is the form that the lesson plan came up with. So did we get this part right? Did we get this right? Yeah, we just made it pi over 6, but it's equivalent. Did we get this right?
No.
We were off by 0.5, weren't we?
I thought it was 10.5.
Oh, we're off by 10.5. So they came up with 12.5 to move it over. Okay, so that 12.5, what's happening here with this is probably the following. Remember when I did y equals sine, we didn't do it in this problem, that's why it's 12.5. But in the problem from Friday's substitute lesson, remember I started off with this, and then I put a radius in there, and the radius was what, 150, I think. I did that, and then I graphed it. And then I build onto it, graphing it each time. So if you did that with this problem, then you could come up with 12.5, or the distance between the two minimum points on there, on the graph. So this would have been apparent had we built it from scratch, but we already fit the curve to the graph, so we had no building to do. We generated our function after that. Alright, so in the future, I guess we can set the rule that is, if you want this item in there, you're going to put the distance between the two crests, or the two minimum points on there, if you're not going to build it from scratch and you're reconstructing it, reverse engineering from after the fact.